Now we're going to get into some basic network troubleshooting. Something that I learned a long time ago and still use to this day is the first step in troubleshooting: know thyself. What this means is when you start trying to fix a problem, you need to know what exactly you're dealing with. Get the lay of the land of your network. The first few things we can check when having a connectivity issue is the network cable and the jack it's plugged into in the back of the computer. Ensure that the cable is plugged in and that the light is on. The light may be green or orange and may be accompanied by another small light next to it. Also, check that the cable is plugged into the network jack on the wall. Next, check to see if the computer can access the internet. Pick a major site that's unlikely to go down, google.com for example. Check to see if you can access the SCLens OPAC from that computer. Lastly, if this is a staff computer, check to see if the staff client can connect. If you're having a problem in any of these areas, we can dig into that next. First, we need to see that we have a working IP address. To do this, go to Start, and then Run, and type CMD and hit Enter. You'll be taken to a command prompt. The command prompt is a powerful tool for working on a Windows computer. With a few simple commands, you can diagnose most network problems right from this little box. Now that you're at the prompt, type in ipconfig space / all and then hit Enter, just as it appears here in the slide. This will give you your IP address information. Here's what my IP address information looks like. Yours will be a bit different. There are 4 things you need for connectivity on the network and to the internet. You need an IP address, a subnet mask, a default gateway, and DNS servers. You may have 1, 2, or more DNS servers. Without one or more of these, you won't be able to connect to the internet or to SCLens. Now we're going to continue on and work on DNS resolution. DNS is a server that provides lookup service to your computer. When you type in a web address, you type in google.com, but your computer does not know where to go to google.com. So what DNS does is it says google.com means this IP address. So then your browser goes to that IP address and requests the information for you. Without this, we wouldn't be able to have easy to remember names for websites. So at the command prompt, type in NSLookup and hit Enter, just as you see here. Type in any web address, google.com for example, and hit Enter. This is what you should see. First, you'll see your default server, and yours will be different, but you should have a default server. Also, its IP address. Then, for the site that you looked up, you'll see that your server responded, and these are the answers with the IP addresses that correspond to this site. As long as you're getting DNS lookups like that, that means that your DNS is working properly. If you get something else, a network timeout or something not responding, that means that you have a DNS issue. Now I'm going to simulate having a non-working DNS server by removing my network cable. So I'll bring in my command prompt and pull up NSLookup, and you'll see that it's unable to connect to my DNS server. It knows the address that it's supposed to be, but it can't contact it. So if I were to put something in like sony.com, I get a timeout and no request. Now I'm going to replug in my network cable. Let's try that again. Now it's working perfectly. We'll try Google again. The next network tool we're going to look at in the command prompt is ping. Think of the game Pong from the early computer days. You send out a request, it sends a reply back. Ping, pong. It's a very easy tool to check and see if you have network connectivity. So bring in our command prompt. And if you're still on the NSLookup screen, you can exit that prompt by typing exit. Now what we're going to do is ping space localhost and then hit enter. You should get 4 replies. This means that you're pinging yourself and that your network configuration software is all working properly on your own computer. I've drawn up a simple network map. Here's my workstation, here's my firewall, and here are 3 addresses out on the internet. And we're going to go through pinging each one of them and looking them up with NSLookup individually. First, we started with localhost. Here's my own workstation. So bring my command prompt back in. Now I can look at my IP address. And here we see my IP address is 10.16.20.70. So I can try pinging that myself. Let me try that again with the numlock on. Four replies from 10.16.20.70. That's myself. That's a good ping. That's a good reply. So next, I'm going to work on the firewall. Now I want to test connectivity now that I know that this is good from here to my firewall. And since I pulled up my my IP address, if I scroll up here, you'll see my default gateway address is 10.16.20.1. So I'm going to ping it next. Okay, so I have 4 good replies to my gateway, also my firewall. So that means that my connectivity inside my network is looking good on this particular machine. Let's see if we can get to the NSLookup server. I'll bring my command prompt back up, and we're going to do an NSLookup on it first. Typed in sclens.lib.sc.us, which is its address. I get a response of 64.57.244.87, which you'll see I've annotated here. So exit NSLookup. Now we'll try pinging it by name. Four responses tell me that DNS is working because I've pinged it by name and DNS had to look it up to get the IP address, which is right here. And now ping is also working, so I have network connectivity from my computer all the way to the NSLookup server. We can ping it by IP address as well. What you should see here is 4 packets sent, 4 packets received with no losses. Also, in the time here, these should all be less than a second. Sometimes, if you have a network connectivity issue that's intermittent, you'll get some packets sent, some packets received. It'll send 4, maybe 2 will come back, the other will time out, and you'll see more than 0% loss. But you really want also, besides 0% loss, you want your time to be less than 1 or 2 seconds. In milliseconds, this is great. This means we have a nice clean path directly to the other end where we're pinging, which in this case is the NSLookup server. Okay, now that we know that this connection is good, we know that our connection to NSLookup can't be the problem. So we're going to go down and test something else. Now we're going to check our connection to Google. just to make sure that we have a good connection to the internet. So we'll bring up our command prompt again. And we'll run an NSLookup on google.com. Now you'll see that Google has numerous IP addresses. Any of these are okay to use. We'll start by pinging it by name. We pinged google.com. DNS replied with one of these IP addresses here. You'll see it's the first one. And then Ping went ahead and pinged that IP address 4 times. We got 4 really good response times. These are 8 and 9 milliseconds, whereas SCLens was 31 and 32. These are both good with 0% loss. Don't worry about the TTL value. Now we'll ping Google by IP address just by hand for good practice. Okay, so we know that our connection to Google is good. I included twitter.com here, but for the sake of brevity, we'll go ahead and assume that our connection to Twitter is also good, since we can connect to Google and we can connect to SCLens. Now that we've tested this connection and we're getting good responses, I'm going to disconnect my network cable again, and we're going to see what it looks like when we can't get a good ping response. Okay. Now that my network cable is unplugged, I'm going to go ahead and back us up all the way back to the workstation. And we're going to play like this machine is having connectivity issues. So first we'll bring up our command prompt. And we'll try to ping ourselves. Okay, my cable is actually unplugged from the wall, but I'm still able to ping myself. So that tells me that my software is working well, but there's a connectivity issue elsewhere that we'll discover when we ping the next thing. So the next thing we're going to ping is our gateway or our firewall. Okay, you'll see here that it sent 4 packets, 4 pings, and received 4, but lost all 4 of them. So each of these pings was unable to reach our gateway, our firewall. Now I'm going to plug my cable back in, and we'll try that test one more time. Okay, my cable is now plugged in. And I'm going to run that ping one more time. Okay, that's a good ping to our gateway. Now we're going to make some adjustments and try to simulate some more trouble issues, and then we'll do some more testing. Okay, next up we're going to simulate having a problem with DNS. DNS is very, very important on your network, and like I mentioned before, your computer connection to the internet will not work if your DNS is set improperly. So what I've done is I've gone into my adapter settings and I've changed my DNS server addresses to be incorrect. So I have 2 DNS servers there, but they're the wrong IP addresses. And this can happen sometimes when you have DNS servers that get a new IP address assigned to them, or maybe the old ones get shut down and replaced with a new one and your workstations don't get that updated information. So we're going to run an NSLookup. Okay, so it shows that 180.129 is my server, but my request timed out. So it's trusting that because I have DNS IP addresses here, that the server's there, it's just taking a long time. So we'll try to look up, say, google.com. Okay, So now we're seeing that the timeout, the request to google.com is timing out. That means we're having an issue with DNS. So let's exit NSLookup. Now we'll check our IP information. Okay, so here we can see our two DNS servers are 10.16.180.129 and 180.78. So let's see if those are correct. So we'll just go ahead and try to ping them. Okay, my gateway is telling me that it cannot reach 129. So that means that there's no server responding on that IP address. That could either be a connectivity issue with the DNS server, or that I've got an IP address specified for a server that does not exist. We'll check our other DNS server here, 180.78. If you hit the up key, it will display the last command that you typed in. Okay, I'm seeing the same behavior. So what I'm going to do is we'll try pinging other things by IP address to tell me if there's a network issue or if it's just my machine. So we'll try pinging myself. Okay, I can ping myself, and we're going to work our way back out to the internet just like we did before. Next, we'll ping the gateway or the firewall. Okay, I'm able to ping the gateway, so that's a good thing. So now let's check google.com by IP address instead of by name. This will bypass checking DNS and allows you to make sure that you have actual connectivity without relying on DNS. Okay, Google's responding. Let's try SCLens. Okay, SCLens is responding. We've used the external IP address they have here. Now we'll try Twitter just for good measure. Okay, all of these are responding properly. You'll see we tested first our connection here, then our connection to the gateway. We tested SCLens, we tested Google, and we tested Twitter. All of these tested okay using the IP address. This means that our connection is good, but for some reason DNS is not resolving the name SCLens, Google, Twitter into an IP address properly. So I'm going to go ahead and pull up my adapter settings, and I'm on Windows 7. Okay, here's my status. Shows that I'm connected, but I have internet access here. So when I go into my properties, check my IP address for IPv4, and check my DNS servers. Now your local network administrator will have these IP addresses, but you want to make sure that they're correct. I know for my network that these are not correct, so I'm going to change them. Hit OK, close that window, and minimize this. Now we'll rewind here, go back to our workstation, And we'll try this again. Now let's try an NSLookup. Okay, see that my server responded immediately and gave me a prompt. So let's try Google. There we are. DNS is working properly now that I've put the correct IP address in there. So let's try SCLens. Okay, I immediately got the SCLens IP address. We'll try Twitter. Okay, so it looks like we're able to query our DNS server properly. So let's exit this. Now we'll try and ping them by name. There you see that ping requested Google's IP address. DNS went ahead and gave us the correct IP address, and then it pinged that IP address for us. You'll see here's the address here. We got good time response, 8 milliseconds. This is a good ping test. So we'll try SCLens now by name. Okay, it's working for SCLens as well, and we'll just for good measure we'll ping Twitter. So now we've worked our way all the way back out here. SCLens is working, Google's working, and Twitter are working properly. That means that our connection to our DNS server is working properly because we can look up the names and the IP addresses via NSLookup, and we can also ping these addresses by their names instead of just using their IP addresses. So not only do we have good network connectivity now, but we also have good DNS connectivity. And that's the end of the network troubleshooting unit. Next up, we'll be looking at downloading and installing the Evergreen staff client.